Okay, what is 26 asking us to find? Concavity. And the easiest thing to do about the concavity is, I know it's given the first derivative, but when the second derivative is positive, it's concave up, meaning we have a relative minimum. When it's negative, it is concave down, we have a maximum, okay? So since we already have the first derivative, why not just go ahead and drive it one more time to find the second derivative? So we have f double prime of x. The first one is negative x squared. For the second one, what rule do we need to use? The product rule. The ones kind of help, so why not? So when I derive the first one, we get minus 1, and you keep the second piece. Then I have plus the negative x. And since 1y is simply 1, we need to put in dy over dx. And on the last one, we have plus 2y, dy over dx. Oh, God. And we're going to plug in the values given to us. What number are we plugging in this one? Negative 1 for the x, and what about for the y?
I think the first point is supposed to be negative 2x, not negative 2x squared.
Negative 2x? That's correct. So we're going to plug in the 1 for the x, for the y, and then negative 1 for the x, right? There it is. There we go. Oop. Peekaboo. And then we would still have to compute what this guy is, because anywhere I see dy over dx, I want to plug in the value of it. Did anyone actually compute that piece?
Is it 0?
It is 0. So if you were to plug in f prime of negative 1 into your first derivative, it is actually 0. And now we're going to plug in for the dy over dx. And that's where maybe you guys messed up on. So we have, if I plug in the negative 1 in here, we get 2. And when I plug in negative 1 times the 1, we get minus 1. And then I get minus a negative is plus 1. dy over dx is 0. Plus a 2. Y is 1. And again, dy over dx is 0. And all that is going to give me a positive or a negative number. Positive. Now, if you want to say 1, that's fine. We have a positive number. So because my second derivative is positive, it is concave up, so we have a relative minimum at negative 1. Boom. I think the hardest thing is trying to figure out what do I plug in for dy over dx.
Yeah.
Okay? All right, let's go on to number 31, was it?
Yes.
Yeah.
Okay, 31 was a little scary because what was not given to us? How many lines are given to us, first of all?
2.
But we only know the equation of what?
1.
Okay. And that's perfectly fine because we were starting at the origin. Ben, go ahead and read this one.
Consider a line from the xy plane to pass through both the origin and point xy on the graph of x on the interval 1 to 4. The figure below shows one such line in the graph that which component is true.
Okay. So we need to figure out what is the equation of this. Now I'm going to kind of go back to algebra 1. Back in algebra 1, you were exposed to mx plus b, correct? When I am deriving this piece, which one does not matter after deriving?
B.
The b does not matter. So everything revolves around the slope. Because the slope has the x with it, we can derive it. So, according to algebra 1, when given 0 to 0, actually, any point actually, this is like, the slope is y over x. How many times am I going to go up and how many across? And what's nice is the y is given as this function right here, so I can plug that in. So when I do, I get m is equal to the given function of x squared minus 4x plus 9 over the x. And I want to simplify that because I need to derive that in the end. So I have m is equal to x squared minus 4 plus 9 over x. Could I rewrite this to bring the x to the top? So we can use power rule. So that's going to give us x minus, was it x? Ooh, did y'all see that I had an x squared?
I was about to mention that.
Yep. The squares are killing me today. So we got 4 plus 9x to the negative 1. So now we're going to take this function, because I need to find the minimum, derivative of the function with respect to x. And that's going to give us dm over dx is equal to Derivative of x is 1, correct?
Yes.
Do I care about this constant?
No.
If I use power rule, we get minus 9x to the power of negative 2, correct? So then I need to set this equal to 0. So I have 1 minus 9 over x squared. Now I'm assuming we all know how to do algebra 1 piece, right?
Yes.
Okay, so we have, what do I do on both sides from here?
-1.
Minus 1. Now since I don't want negatives, can I also move instead move negative 9?
Yes.
Okay. If you want to move the minus 1, that's okay, nothing wrong with it. Okay, and then I'm going to cross multiply. So I get x squared is equal to 9, so x must be how many?
3.
X must be 3. So when I'm testing my critical numbers, we know we have our x, we have our 3, but don't we also have the bounds that we need for the endpoints? 1 and 4? And we are plugging it into the slope function. And by that, the equation of this. And I'm going to write this equation back on here so we know which one to refer back to, because it gets quite redundant. Hi.
Can I put this so I can pull down your remote?
Yes. Well,
You need a minute?
it's an AC, right?
Yeah.
Could I get like 5 minutes to finish? Because I'm recording right now. 7 minutes. Thank you. AC. All right. Let's go fast. Let's plug in the 3. We get 3 minus the 4 plus 9 over 3 is 3. That's going to give us 2. On the next one, we get 1 minus the 4 plus a 9. That's going to be 6. Then I have 4 minus the 4 plus 9 over 4 is simply 9/4. And reading the instructions, look at letter C. The minimum passes through the equation at x equals 3. Is that true? Is 2 really the smallest number? Yes, it is. So that one was a tough one. Only because we don't think about mx plus b and b doesn't matter, so we completely ignore that part. Okay, pretty in depth. Okay, let's quickly go over number 32. All right. For number 32, Wesley, let's read.
Which the following describes the y-coordinate of the point on the curve e to the power of x equals sine y in the xy plane where the curve has a vertical tangent line.
So again, anything with the tangent has to do with the slope, right? So we want to go ahead and derive this. So when I derive e to the x, isn't it just e to the x? It's really e to the x times 1, but we don't need that 1. Now, for the next one, we have sine. What is the derivative of sine? Cosine y. Because we're messing with something with the y, we need dy over dx. Any questions on that one? Now let's solve for dy over dx. That's going to give us e to the x over cosine of y. Because I want to figure out where there's a vertical tangent, which means we're dividing by a 0. I want to set cosine y when it is equal to 0. Well, 0. Okay, y'all need a review on the coordinates? Yay or nay? Can I just say pi over 2?
Yeah.
Are we okay with it?
Yeah.
If not, do you want me to draw it?
Yeah.
Draw or not draw?
Yeah.
Okay, so we know pi over 2. And the one that's got pi over 2 is every single one of them, which does not help us, right?
Yeah.
Now, here's the other idea. Can e to the x ever be a positive or a negative?
Negative.
E to the whatever is always?
That's-
Let's write that out. E to the x is always positive. And looking at this piece, we're looking at, we have our equation is pi over 2. Cosine goes in a cycle of 1 pi or 2 pi? 2 pi and 2 pi n. And our answer for this one should be D.
Where'd you get the 2 pi in again from?
2 pi basically means when I'm starting at pi over 2, I go in a coterminal. Full circle is 2 pi. You go over and over and over in a circle.
Oh, because on the graph it like takes
Mhm.
okay.
Yep.
I'm still confused. Wow.
The region of the depths.
Okay.
What if it was sine?
What if it was this right here? What about this? Non-negative.
That'd be just that'd be A, right? Because it goes.
It'll be if it were to be on the bottom 3 pi over 2, then we would have to include that piece.